let's continue with our second example of an integrand with a single term and using U substitution to evaluate an integral where the integrand is just a single term. So this is the example we're going to look at, the integral of the natural log of square root of x dx. Step 1, of course, is to find a good choice for u and dv. Since our integrand has a single term, dv is just going to be dx, and u is going to be that single term, which is going to be the natural log of square root of x. Now, if dv is equal to dx, then v is x. If u is equal to natural log of square root of x, what is du? We're going to need to use the chain rule. So to use the chain rule, we've got the natural log of square root of x prime. Our outer function is natural log of x, and our inner function is square root of x, which we can actually write as x to the 1/2. So if we remember our formula for the chain rule, it said that if you want to take the derivative of the composition of two functions, f of g of x, you need to take the derivative of the outer function, evaluate it at the inner function, and multiply that by the derivative of the inner function. So for us, our outer function is natural log of x. Our inner function is the square root of x. The derivative of our outer function is 1 over x, and the derivative of our inner function is 1/2 x to the minus 1/2. Remember, take that coefficient, bring it down. The exponent turns into your coefficient, and then your new exponent is the old one minus 1. So using our formula, we're going to get f prime of g of x times g prime of x equals, now what is f prime of g of x? It's going to be 1 over g of x, right? Because f prime of x is 1 over x, so f prime of g of x is 1 over g of x, times g prime of x, which is this 1/2 x to the minus 1/2.
It's 16:15.
Okay, and then what is 1 over g of x? That's going to be 1 divided by g of x is x to the 1/2 times 1 over 2, and we actually have x to the 1/2. So our derivative ends up being 1 over 2x. I'd like to point this out. Imagine if we had started off by rewriting the natural log of square root of x as the natural log of x to the 1/2. Using our rules properties of log, we would have rewritten this as 1/2 natural log of x. Then it's a lot easier to take the derivative. The derivative would just be 1/2 the derivative of natural log of x, which gives us 1/2 1 over x, which is the same answer we got when we used chain rule. So over here we'll have 1 over 2x dx, don't forget dx, and we're ready to apply our formula. So the integral of natural log of square root of x dx is equal to, we need uv minus the integral of v du. What is our u? U is natural log of x. V is x minus the integral of v, which is x, and du, which is 1 over 2x dx. So, rewriting, we'll get x natural log of x minus the integral of, these x's cancel out. This x in the top and the x in the denominator will cancel out. And we'll just have the integral of 1/2 dx, which is not that bad compared to the original integral that we needed to evaluate. We know that the integral of 1/2 dx is equal to just x over 2. Okay, then we'll put a plus c for a constant. So that is going to be our final answer. X, natural log of x, minus x over 2, plus a constant.